So hi, this is Julie, and I want to talk about a couple of other things we see when we're working with branching. And that's Boolean data types, and then some odd little things that can happen when we're comparing floating point numbers. But first, let's talk about the Boolean data type. Sometimes we're going to want to work with Boolean variables, and what are these? Well, these are variables that can only have two possible values. These data types or variables are either going to have a value of false, which is the number 0, or they can have a value of true. And when we look at true, we're going to generally say true is equivalent to 1, but it's really going to be anything that's not 0. So these data types only have two values. We'll often compare them to the reserved words false and true. And the way I'm going to create this is I'm going to use bool as my data type. Here I have a variable named freezing, and I'm initializing it to a value of false. Now I can compare the temperature to 32 to decide if I want to change freezing's value. And if the temperature is less than 32, and this would be 32 degrees Fahrenheit, then I want to change freezing's value to true to say, yes, it is freezing. Once I've set that variable's value, later on I can look at its value to decide if I want to execute some code. So here I want to display a message if it's freezing. I've already set the value of freezing to either true or false, and now I'm going to compare its value to true. So I can say if freezing equal true, meaning is the value of my bool variable freezing true, and if it's true and I compare true to true, and they're both true, then the whole statement's true. I'm going to say it's freezing, and now I can display a message to watch out for ice. I can even write this a little bit simpler way. I don't even have to compare it to true. I can say if, and just put freezing in parentheses. If freezing has a value of true, then this test condition will be true, and then again I will execute the code that says watch for ice on the console window. So why do I want to do this? I could have said if temp less than 32, watch for ice, and that would do the same thing. But sometimes I'm going to do this because I want to simplify an expression. So let's say I want to see if somebody owns pets. And I'm going to look at the number of cats and the number of dogs that they own. And if they have one or more cats or one or more dogs, or in other words, if cats greater than 0 or dogs greater than 0, I'm going to say that they're a pet owner, and I'm going to set pet owner to a value of true. Now later on, if I'm wanting to decide how much apartment rent to charge someone, all I have to do is say if pet owner in parentheses as my expression, and if they are a pet owner, then I can increase their rent by $30. I could have had the same expression with the cats and the dogs, but now instead I've created this one variable that's going to stand for that complete expression of the cats or the dogs. And then I can just use this pet owner variable as a flag later on in the program to decide what I want to do. Another thing that I can see sometimes when I'm comparing data for branching in if statements is some situations with floating point numbers that might be a little different from what you would expect. Now, when I compare numbers for equality, if I'm thinking about math and two numbers have the same value, I would say that they're equal. And with real numbers, I would still think of it that way, but with computers, floating point arithmetic is going to work a little bit differently from real number arithmetic. In the world of integers, I don't have a situation to be concerned about, but here I'm talking about floating point numbers, and sometimes we'll see a few little odd things happen. So let's take this variable pi that's a type double, and I'm going to initialize it to 3.14, which is a standard value people might use in mathematical problems for pi. Once I've initialized that variable, I can display its value on the console window. And let's say I want to display 17 digits, or 17 decimal places rather. I'm going to use set precision here of 17 and display pi. And what I'm going to see here, instead of exactly 3.14, I have a number that's extremely close to 3.14, but not exactly, because the way the number got stored in the computer, it actually had a 1 way off to the right as a very insignificant digit. But even with that 1 out there, now if I compare pi to 3.14, they aren't going to be exactly equal. I can also see that when I'm working with two numbers that seem like they have the same value, but one of them was created through addition and the other was created by assigning it to a literal. So my first double here is named 1, and I'm going to initialize it to 1.0. The second variable here, named 1 again, is initialized by adding 0.1 to itself 10 times. And in math, if I add 0.1 10 times, I'm going to have 1.0, exactly 1.0. But it's not going to work quite like that in my C++ program. And if I were to display both of these variables, I can see what number they actually have stored. The first one that I initialized to 1.0 is going to display the value of 1. The second one, however, displays with a number that's almost 1 but not quite. And now if I compare the two variables with the equality operator of the double equal sign, they are not going to be the same, and this program is going to display different, not same. So essentially they are the same, and we're talking about an extremely minuscule difference, but they are not technically the same number. So what can we do about this situation? I might need to compare these numbers for some reason in a program. And for my purposes, these are basically the same number. So I'm going to have to do something where I allow for small differences. And in order to do this, I am going to figure out what the difference is in these two numbers and see how big the difference is. So I'm going to write it like this. I'm going to take 1 again and I'm going to subtract 1. And I could do it subtract either one from the other one. And I'm hoping to get an either extremely small positive or extremely small negative number. I don't really want to worry about whether it's positive or negative, so I'm going to take the absolute value of it. And the absolute value of the difference, if the difference in this case is less than 0.0001, it's an extremely small difference, I'm going to go ahead and say these are the same. But if the difference is bigger than this amount, then these numbers may be very different, and then I'm going to say that these numbers are different. So, for the two numbers that I had here, the 1.0 and then the other number where I added 0.1 10 times, if I were to execute this code, then when it ran, it would display the word same because they're close enough to the same that they have an extremely small difference.